Chord.
Okay.
What kind of problems do you want to go over? What
Okay.
differentiation
So
problems, huh?
they're derivative problems. I have a big derivatives test. That's what this is called.
Okay.
Okay, so I have, so the first example, let me think. I'm actually going to do, I did all the multiple choice already, so I'm going to go over the not multiple choice stuff. Okay. Okay. Just 1 second. Okay. Alrighty. So first one, here's a good example. So it says find the derivative of each function, y equals 4x, then square root x squared minus 6.
Like that?
Yes, sir.
Okay. So,
Perfect.
first of all, we see we have a product here. Because
Yes.
I can't multiply those two things together.
Right.
Not multiply 4x times square root of x squared minus 6. So it's going to be the product of 4x, that function, times the other function.
Okay.
So let's talk generally here for a second. If y equals, I'm going to use u and v, which is pretty common in calculus. So if y equals one function times another function, then y prime equals u v prime plus u prime v.
Yes, sir.
Using the product rule. Okay.
Yes.
So
Yes.
in our case, tell me what u v prime is.
Okay, so first, well, u is going to be 4x, right?
Huh?
Okay, and then the derivative of a square root, so that's technically x squared minus 6 parenthesis 1/2, right?
That's the way to write it. In other words, radical signs don't do a lot of good in calculus.
Right.
But as long as you have fractional exponents, that's the same thing and far more useful.
Right.
So what's the derivative of that part there?
1/2 x squared minus 6 to the negative 1/2?
Yeah. Except we still need to apply the chain rule.
Okay.
In other words, we just took v prime, and v is this x squared minus 6 to the 1/2.
Right.
So
right.
v prime is 1/2 of that quantity to the minus 1/2 times the derivative of the inside, which is what?
That is going to be 2x, right?
Okay, yeah. Now, the reverse of that.
Okay.
So what's u prime v?
So then, the prime of u is going to be 4. So plus 4 times, is it still just going to be x squared?
Whatever it was, yeah.
Yeah.
In other words, we're not differentiating that part on this.
Yeah, perfect.
So that's going to be our answer. There's a little simplification you can do. There's that. So what does that give us? 2x times 2x. So that's actually 4x squared.
Okay.
Times x squared minus 6 to the minus 1/2 plus 4 times the quantity x squared minus 6 to the 1/2.
Awesome.
And that's a reasonable answer. In other words, I don't see any need to simplify that. No need to factor the 4 out. Can't do anything with it.
Okay.
So, what else?
Awesome. Okay. So then, next question. It says y equals 5 root x, square root x, and then parenthesis 2x to the power of 3/2 minus 6x to the power of a negative 1/2.
Like that?
Yes, sir.
All of that's the multiplier?
Yes.
Okay, well, very first thing, let's write it without radical signs.
Yes.
Make sure I wrote this correct.
Okay.
Now, don't necessarily need to use the product rule here.
Okay.
Because I can multiply these. I can multiply 5x to the 1/2 times 2x to the 3/2. What's that? Let's distribute it. What do we get? That.
Would that be 10x to the power of 2? Because if I'm not mistaken,
Yeah.
okay, yeah.
Add the
Add the exponents? Okay.
Okay, and the next term?
And then that one would be minus 30x to 0, which would be just 30, really.
Correct.
Okay. To the 0. So it's
So that's what y is.
okay.
So now y prime, I don't need to do much, but differentiate both terms. What's the derivative of 10x squared?
That would be 20x.
What's the derivative of minus 30?
0.
There's my answer.
Awesome. Okay.
So
now,
if you can multiply them together, do so because you'll avoid having to use the product rule
okay.
and also the chain rule. In other words, if I had to actually deal with these as the product of two different functions, then there would be my two functions and it would be a lot more complicated. But
that's
the fact that I can multiply them together simplifies the problem so significantly. Don't have to use the product rule, don't have to use the chain rule.
That's awesome. That's awesome. Perfect. Thank you. Awesome. So for the next one, it is y equals 4 times h to the 5th of x. It's technically like h of x equals 4 times h to the 5th of x. But I just replaced the h of x with a y.
Hold on, what was the original problem?
So it says h of x equals 4 times h to the 5th of x. Yes, perfect. That was it, yeah.
All right. Well, if I move one of these, hold on a second. So this is the way they gave you the problem.
That is, and it had a multiplication sign between the 4 and the h as well.
Okay. Well, it certainly seems like 1 should be equal to 4h to the 4th of x.
Okay.
So h to the 4th of x should be 1/4.
Okay.
And h of x is going to be the 4th root of 1/4.
So then h of x is going to be the 4th root of 1/4. Okay. So
Which is, so h of x is 1/4 to the 1/4 power.
Okay.
Well, that's 1/2 is the square root of 1/4. So h of x is going to be 1/2 times, no, hold on a second. It's the, So it's the square root of 1/2.
So it's the square root of 1/2.
Which is 1 over root 2, or rationalized root 2 over 2.
Okay.
Now, let me look at this for a second. I'm not used to seeing problems like this.
And that's the only one that's like that, too. So I don't know if she would have that problem on there. I don't know if she just threw that in to just try and get us thinking. But
well, it's definitely a problem that tries to get you thinking.
Yeah,
yeah. Question is can I divide both sides by h of x? And I did, and then I divided both sides by 4. So I don't see why you wouldn't be able to do that. You wouldn't be able to necessarily divide both sides by h of x if it was ever equal to 0.
Okay.
In other words, the way I actually did that probably was not the best way. The more I think about it, because one thing I've discovered is that if you divide both sides of an equation by something that could be 0, and 0 is one of the possible solutions, you lose it. Just like I lost this one. Notice nowhere do I have h of x equals 0. But clearly, if h of x was equal 0, this would still be a valid equation, the second row.
So there's multiple answers to this then.
Well, here's the way I should have done it. I should have subtracted h of x from both sides. So I get this as my next step. And now if I factor out an h of x, I will get h to the 4th of x minus 1. And notice now I have two solutions. H of x equals 0 or x equals the 4th root of 1/4. So I re-picked up that solution, which is obviously a valid solution.
Right.
And if you want to get it, the only way to do it is to not divide both sides of the equation by h of x, but to subtract h of x from both sides of the equation.
Okay.
Okay. And when I do that, I get this.
Right, right. That makes sense. Which
gives you the 0 solution also.
Right, right.
Which comes back into the equation. But once you've divided both sides of an equation by a variable that might be 0, if that variable's one of the answers is 0, you will lose it. You won't see it anymore. And that's exactly what happened the way I did it, by dividing both sides by h of x. So you really want to subtract h of x from both sides.
So that way you pick up the 0.
And then factor it out, yeah. Now, after I subtract it from both sides and factor it out, I get that.
Okay. I understand that. That makes much more sense now.
All right.
Okay, perfect. Alrighty, so for the next one, it is y equals 4 over x cubed minus 6 over x to the 4th plus 9 times root. It's the cubed root of x squared, actually. Perfect.
Okay.
And that is it? Yep.
One thing about differentiation is that when you have a polynomial that's got different terms like this, you can differentiate each one on its own. Okay? And the only thing I'm going to need to use here are the power rule.
Okay.
I've got to write that way.
Right.
minus 6x to the fourth plus...
And it's actually, it was 6x to the negative fourth. The initial equation was 6 over x to the fourth.
That's fine. Okay, so write it like that. And then this is going to be x to the 2/3.
Okay.
That's what you get when you take the cube root of x squared.
Right.
When you have a fractional exponent, the bottom, the denominator is the root, the top is the power.
Okay.
So now that I've written this properly with respect to calculus,
right,
just differentiate each term. What's the first term?
So it's going to be negative 12, negative 12x to the negative fourth plus 24x to the negative fifth, because it would be negative 24, but
yep.
And then plus, let me think, so that would just be 6x to the negative 1/3, right?
There you go. Now, if your teacher does not want negative exponents ever, then you'd want to write it like this.
Okay.
In other words, I can write that answer with all positive exponents.
Okay. Okay, that makes sense.
There you go.
Okay, that makes sense.
Y prime, excuse me.
So both, okay. Awesome.
Okay.
Alrighty, now the next one, number 5. Y equals 3 times, and then it's to the power of 4 plus 3x.
Like that?
Yes, perfect.
Okay. All right, if I have y equals some number to the x power, what is y prime equal to?
I'm not quite sure.
Well, you can't use the power rule because the exponent is the variable.
Right.
So if that was e to the x, then y prime would be e to the x.
Okay.
So one way I remember it is it's this divided by the natural log of a.
Oh, okay, okay.
Hold on a second. You end up not doing a lot of base 3 when you get to calculus. In other words, you end up doing, I don't quite have it right. Yeah, sorry. It's times the natural log of a.
Oh, okay, okay.
And then, of course, we need to do the natural log of the derivative. In other words, here's what it really is. Let me write it over here on the upper right. If I have a to the u, and I'm differentiating that with respect to x, then it's going to be the natural log of a times a to the u times u prime. In other words, that's the derivative of the outside, that's the derivative of the inside. So I do need to apply the chain rule.
Okay.
Okay, so what's the derivative of the inside? In other words, I've almost got the answer here, but I need to multiply it by the derivative of the inside of u. In other words, that's u.
So the derivative of that is going to be 3, right?
Uh-huh. So there's your answer. Now, usually when you have natural logs, you don't want a number on the right side because it's confusing. Am I taking the natural log of 3a or am I taking the natural log of a times 3? Well, I'm taking the natural log of a times 3. So I'm going to write that like this.
Okay.
And then there's no confusion.
Okay.
Okay?
Makes sense, I see.
Because there is a significant difference between the natural log of 3a and 3 times the natural log of a.
Right.
3 times the natural log of a is actually the natural log of a cubed.
Okay.
Okay, so it's not the natural log of 3a. So where you put the 3 kind of does matter just for clarity's sake.
Right. Okay, that
I'm
makes sense.
taking the natural log of 3a. I'm taking the natural log of a times the number 3. So I'm going to put the 3 in front.
Okay.
All right.
Perfect. So that is the final answer?
That's the final answer, yes.
Perfect. Alrighty.
Now let me just ask a question or two. You've obviously had the power rule, the product rule, the quotient rule, and the chain rule, correct?
Yeah. Yes, I know all of those. I'm very familiar with those.
Implicit differentiation yet?
We have. That is on this test. I do know generally as to what I have to do with that. I know that's if there's two variables, you have to derive it implicitly.
Let's take one really simple.
Okay.
Equation of a circle. Find dy dx.
dy dx.
Or differentiate that with respect to dx. And if I do the left side, I'm going to do the right side. Just like any algebraic equation, you can do anything you want to the left side as long as you differentiate the right side.
Right.
Now the left side, you're going to take it term by term. So when you differentiate a variable that's x, you just differentiate it.
Okay.
That's 2x.
Right.
But when you come to a variable that's not x, then you differentiate it, but you follow it with a dy dx, because y is not the same as x.
Okay.
That's all you need. In other words,
that's like a y prime then too,
if you
technically?
come across any variable whatsoever that's not x, then you have to follow it by a d of that variable divided by dx.
Okay.
And the right side is 0, because the derivative of a constant is always 0.
Okay, yeah.
Notice I can solve for dy dx. I've implicitly differentiated it. I'm going to call that y prime.
Yeah.
And it's going to be minus 2x. I'm going to take that on the other side, divided by 2y. 2's cancel, and I get minus x over y. And what's significant about that answer is, first of all, the answer has both x and y in it, which is different. When you explicitly differentiate something, it usually only has x in the answer.
Right.
Nothing wrong with having an x and a y. What I gave you to start with was the equation of a circle.
Okay.
So if I want the slope, which is what the first derivative is the slope, and I want the slope of the tangent line at some point, well, you're going to give me an x and a y coordinate. Let's say 3, 4. Well, if I go to 3, 4 right there, that slope is going to be minus 3/4, because we just figured out that the first derivative is minus x over y.
Okay, so that is how you solve the slope of the tangent line at a certain point, by plugging in the x and y.
Yeah. In other words, if you're dealing with a function, well, this actually is not a function. Notice that we started with a circle, which is not a function, it's a relation.
Right.
But we can still implicitly differentiate it and solve for dy dx, which would be the slope at any point on the circumference of that circle. Notice that if I'm interested in that point there, then I'll plug in the appropriate x and y. And it's a negative x, a positive y, so I'm going to have a positive slope. If I want the slope down here, I'll plug in x of 0, whatever the y is, the slope's going to be 0. That slope is flat.
Right.
In other words,
Okay.
with implicit differentiation, it's okay if it's in terms of x and y, because
Right.
you're always going to give me an x and a y. If you just give me the x, that's also fine, because I can calculate what the y would have to be.
Right.
Almost. If you give me the x, the y is equal that point or that point. So
Right.
that's what makes it not a function.
Okay.
But if you give me the appropriate x and y of these 2 points, I'll get a negative slope and a positive slope.
Right. Okay.
And
Okay.
related rates are, or I should say implicit differentiation is a vital part of solving related rates. Related rates are the real world problem
Right. Yeah, and that is covered over in this
solved
text
by
too.
implicit differentiation. And it's difficult to solve by any kind of other differentiation. The reason implicit differentiation is valuable is because sometimes you can't solve something by regular differentiation. If
Okay.
I have something like x squared plus xy plus y squared plus 2, I can't solve for y. I have no idea how to solve that for y.
Right. Right. Yeah.
But I could implicitly differentiate the entire left side. So
Right.
that would be 2x plus, and then I'm going to use the power or the product rule for that term.
Yeah.
So it'd be the first time times the derivative of the next, which is dy dx, plus 1y plus
Right.
2y squared, because y is not x, I got to follow it by a dy dx,
Right.
equals 0. Now, to solve this one for dy dx, I gather this term together with that term, factor out a dy dx, move everything else to the other side,
Right.
and so forth and so on.
Perfect.
In other
That
words,
makes
you can certainly implicitly differentiate that, which would be near impossible to explicitly differentiate it. Because for me to explicitly differentiate this, I would have to solve for y. And some functions are not that easy to solve for y.
right.
This is one of
Right.
them. I would have no idea how to solve that for y.
Exactly. Okay, that makes sense. I see. Perfect.
Max, my first free session is a half-hour long.
Yes, that's right.
We're at the end of that.
Yes, sir.
And let's see. What else do I need to tell you? I've recorded this, and I will make that recording available to you.
Okay.
It probably won't get up until tomorrow morning, because I
No
have
worries.
sessions the rest of the day, and my computer has to process these files overnight.
Okay.
So
Perfect.
I will send you an email in the morning telling you how to access this recording.
Sure thing.
And let's see, in terms of future sessions,
Yes, sir.
you had mentioned you maybe want an in-person session on Friday.
Yes, sir. If I could, that would be awesome.
I could meet you at Highlands Ranch Library. Would that work?
The Douglas County Library?
And the Highlands Ranch Library is the only one I'm familiar with. It might be the same one as what you're calling the Douglas County.
Is it the one right by Civic Green Park?
I don't know where that park is, but it's the one right off of Highlands Ranch Boulevard, pretty close to Broadway.
Highlands Ranch Parkway and Broadway, like at that Safeway
Ridge
area,
Road.
stuff
Ridge
like
Road.
that.
Ridge is about a block west of Broadway.
Perfect. Yep. I know exactly what you're talking
You know where
about.
that is? Okay.
Yes, sir.
That opens on Friday at noon, and I believe is open until 5. And you're looking at my Friday schedule, so I could do whatever time you want other than 5 to 6. So I guess we have to do it sometime between noon and 4.
Okay.
Pick a
Do you think
time.
I could do? Do you think I could do like a 3:30 to a 4:30 on that day?
Yeah, that'll get me home by 5. Let me hold on a second. Let me put it down like this.
Okay.
Put it down as a 3 to 5. That gives me a half-hour travel each way. And
Perfect.
it's Max Nelson.
Yes, sir.
And let's see. I'm sure you left your email address. What phone number is the best number to reach you at, Max?
303
Uh-huh.
882 7817.
All right.
Perfect.
And what I will do is, if you're familiar with that library, there's only one entrance. It's a double door.
Yes.
I'll meet you inside the library right on that entrance. Right on
Okay.
the other side of those double doors, the inside.
Perfect. Sounds good.
I will
Perfect.
be there at 3:30, and I will try to reserve a study room upstairs, so
Okay. Perfect.
a place that's quiet and we can talk. And
Okay.
bring your textbook plus anything you want to work on.
Perfect. And I was also curious, do you have any more availability for online sessions at all?
Yeah, you can see my schedule there. So
Okay.
I have an hour and a half available tomorrow
Okay.
between 4:30 and 6. I also
Okay.
have an hour available between 7 and 8 on Wednesday.
Okay.
And I have a couple
Um,
3 to 4s available on Wednesday and Thursday.
okay. Now here, do you think you could do a little earlier in the day on Tuesday? Do
Yes,
you think
I can always
potentially
do
like,
earlier in the day as long as, in other words, this person's actually scheduled something from 7:30 to 8:30,
oh, okay.
and
Okay, perfect.
that's fine. So I can do something after 8:30 on that day.
Okay, so on Tuesday,
Hmm.
could I do like a 1:30 to a 2:30 tomorrow?
Yes.
Perfect.
That's going to be online,
Yes, sir.
1:30 to 2:30.
Yes, sir.
Okay. And
Alrighty, and then other than those two right now, after tomorrow, if I feel as if I need more, then I will schedule more. But those two right now should be pretty good for me so
okay.
far.
And as I said, you can always go to my website. The website
Right.
actually to use is Digital Math Tutor. That's the one I sent you.
Yes. Yes. Yeah. I have that. I have that website all
And
pulled up.
that
I found the
will,
scheduling, automatic
yeah, if you
scheduling
need
just
to
now.
change any appointment, you can go ahead and find an opening, go ahead and schedule it, and then notify me, and I'll cancel the original.
Okay. Perfect. Awesome. Thank you so much, man. I appreciate it.
Yeah, you're welcome. Yeah, for most students, in terms of payment, if
Yes.
you're a 100% online student, most of them
Yes.
pay with PayPal.
Okay.
And that's probably the easiest way to pay.
Right.
It's okay with me if you want to send me a check since you're local in town.
Right.
But as long as we have an in-person session on Friday, you're welcome. And if you want, you can pay for that session along with Tuesday's session at the same time.
Okay. Okay, yeah, my parents will probably just ask me how much I need to owe you, and then they'll just give me cash on
That
Friday.
would be $72. In other words, your
For
Friday
72
in-person
bucks.
session will be 40, and your online session tomorrow will be 32.
Perfect. Awesome. Sounds good.
Okay,
And then, well, I'll do the math if it were to change or if anything else were to happen.
sounds good.
Um,
Otherwise,
Perfect. Well,
Max, what I'll
other
do
than,
tomorrow is I won't call you. I will just text you the meeting ID number.
cool beans. Awesome. Thank you so much, sir. I appreciate it.
You're welcome. Talk to you tomorrow, Max.
Yep. I'll talk to you soon.
Bye.
Bye.